Let's look at problems 5 through 12. They all have the same direction here. I've done a little bit of preliminary things. You should know that the boundaries for all of our quadrants, whether you're in degrees or radians. So with 236 degrees, you're obviously bigger than 180 degrees and smaller than 236. So if we estimate what this angle is, here's a sketch of 236 degrees, and it lies in quadrant 3. That's one answer they wanted. Anytime that we have an angle that's between 0 and 360 that lies in quadrant 3, our reference angle will be that angle minus 180. This angle of 236 minus 180 degrees. What we're doing is finding this angle, this angle that's with respect to the x-axis. I don't want to make a silly sign error. $56 degrees. That's our reference angle. All right. 721 is bigger than 360. So I have to think in terms of coterminal angles. Coterminal angles have the same initial side and the same terminal side. So if I start with 721 and I subtract 360, I'm still above 360. So I subtract 360 again, and I'm at 1 degree. So 721 is coterminal to 1 degree. So 721 has the same terminal side as 1 degree. It's just that it wraps around not once, but then twice, and then just that little part of 1 degree. Okay, if our angle, so we are in quadrant 1. Any angle that is in quadrant 1 is its own reference angle. Now, 721, our reference angles are always acute angles. So first with 721, we found its coterminal angle, and then if you're between 0 and 360, then that angle, if it lies in quadrant 1, if it's between 0 and 90, is its own reference angle. I don't have to subtract anything or add anything to it. So the reference angle for 721 degrees is 1 degree. And we say that 721 degrees lies in quadrant 1, so does all of the coterminal angles that coterminal to 721, which means that 1 degree also lies in quadrant 1. Now, this 0 was our initial point. Our 1 degree was right here. That's exaggerate. That's not drawn to scale. Negative 244. Negative angle measures are clockwise direction. We need to add 360 to get a positive angle. So I need to add complete revolutions. 116 degrees is coterminal. 116 degrees is coterminal to negative 244. 160 degrees is bigger than 90 but smaller than 180. Now, I know that negative 244 wrapped around this direction, and what I just found was the angle from here to here being 116, because I wanted an angle that was between 0 and 360. If I'm in quadrant 2, and that's where these angles lie, their terminal side lies in quadrant 2, then it's always 180 degrees minus the angle. My reference angle, the angle that I'm going to make with the x-axis, is always going to be if you're in quadrant 2, which we are, it will be 180 degrees minus this angle of 116, because 116 was coterminal to negative 244, and it was between 0 and 360. I don't want to make a silly sign error. Let's jump to the calculator or arithmetic error. 64 degrees. That's an acute angle, and that's in red right there. That's the 64 degrees, the angle that it makes, that this terminal side makes with the x-axis. If you're in quadrant 2, the reference angle will always be 180 degrees minus that measure of that angle that is between 90 and 180 that lies in quadrant 2. Negative 775. That's going around clockwise. We have to find a coterminal angle that's between 0 and 360. So I'm going to start adding revolutions of 360. If it was extremely negative, then I would divide and estimate how many revolutions it's going to take. But this is just so easy to go ahead and keep adding complete revolutions. And now all of a sudden on the third one, we're here. 305. So I know that negative 775 degrees is coterminal to 305 degrees. And I know that 305 degrees going counterclockwise is between 270 degrees and 360. So this is this angle, 305 degrees. My reference angle, I'm in quadrant 4. If the terminal side of the angle of interest lies in quadrant 4, the reference angle will be 360 degrees minus this quadrant 4 angle. So in this case, it's 360 minus 305, which should be 55 degrees. So my reference angle is an acute angle. It's between 0 and 90, and it is the angle that is from my terminal side to my x-axis, the smaller angle. If you're in quadrant 4, it will always be 360 minus that quadrant 4 angle. So this is one answer. This is the other answer for the reference angle. Now they've given me the angle measure in radians. I need to know my cutoffs for my boundaries in radians. 0 radians, see, it doesn't have the degree symbol, so I know I'm in radians. Pi over 2, pi, 3 pi over 2. 2 pi is 1 complete revolution. When I look to 13 pi over 5, with this denominator of 5 and these denominators of 2, it's too difficult to compare these fractions without a common denominator. So if you multiply by 2 over 2, you'll get a denominator of 10. And so what I did with each boundary, here I multiplied by 5 over 5 to get a denominator of 10. Here 10 over 10. Here another 5 over 5. And here a 10 over 10. So now my cutoffs all have denominators of 10. 26 is bigger than 20, so I'm making more than one revolution. I need to subtract complete revolutions. So if I subtract, to find a coterminal angle, if I subtract 20 pi over 10, then 26 minus 20 is 6, and I'll have 6 pi over 10. And now I can look at 6 pi over 10 and say 6 is bigger than 5 pi over 10, and 6 pi over 10 is smaller than here. So I know that the terminal side of this 13 pi over 5, even though it's going around more than once and coming up here, I know that I can use this coterminal angle of 6 pi over 10. Now I would probably begin to reduce this and think of this in terms of 3 pi over 5, and I am in quadrant 2. If the terminal side of my angle lies in quadrant 2, then the reference angle will always be pi, or 180 degrees, pi minus this angle of 3 pi over 5, the one that was coterminal to the original angle of 13 pi over 5. They lie in the same quadrant. If I subtract 13 pi over 5, I need to get a common denominator, so my reference angle is 2 pi over 5. That reference angle is the angle that it makes with the x-axis. This terminal side, the angle that it makes with the x-axis. So let's see, I was in quadrant 2. They wanted two things: determine the quadrant and then determine the reference angle. And my reference angle for 13 pi over 5 is 2 pi over 5. 13 pi over 5, that terminal side lies in quadrant 2. So again, they give me another radian measure. Again, it has a denominator of 5. So when I look to my boundary, the denominators of my boundary with 2, the least common denominator of 5 and 2 is 10. So I multiplied this by 2 over 2 to get 44 pi over 10. I multiplied this by 5 over 5. I multiplied this by 5 over 5. And the others I multiplied by 10 over 10. Alright, so now I compare. 44 is bigger than 20, so I need to start subtracting complete revolutions. And since I know the denominator is 10, I can just start subtracting multiples of 20. So when I take 44, instead of 44 pi over 10, I'm just going to take 44 minus 20. That was one revolution. I get 24. That's still bigger than 20. So I take away another revolution, and I get 4. So I know that 4 pi over 10 is coterminal to this 22 pi over 5. The terminal side of these angles lie in the same quadrant. 4 pi over 10 is bigger than 0 but smaller than 5 pi over 10. I am in quadrant 1. So when you're in quadrant 1, the reference angle is this acute angle, is this angle that was between 0 and 2 pi that we found that was coterminal to 22 pi over 5. So my reference angle is, I'm in quadrant 1, it is 4 pi over 10, but 4 and 10 are both even numbers, so that reduces to 2 pi over 5. So this 22 pi over 5 lies in quadrant 1, and 22 pi over 5 has a reference angle, an angle that is the terminal side to the x-axis of 2 pi over 5. Now, instead of giving me the radian measure in terms of pi, they just gave it to me as a decimal number. So I came over to my boundaries of pi over 2, pi, 3 pi over 2, and 2 pi, and wrote those decimals. You're probably most familiar with recognizing pi as 3.14 as a decimal approximation. This was 2 decimals, so I just rounded this to 2 decimals. Negative 5.21 is going in the clockwise direction, and I need to add a complete revolution. I need to add 2 pi to this and get a number that's between 0, a decimal number that's between 0 and 6.28. So rather than adding the 6.28, I'm going to be a little bit more exact and add 2 pi and try to keep the round up, since the calculator knows what pi is. So if I add 2 pi, I get a decimal number, and let's just round it to 2 decimals. Of 1.07. So 1.07 is bigger than 0 and smaller than 1.57. So I know that although you're going around in a clockwise direction, that when you come around here, that terminal side, I know that this angle right here is 1.07. I know that this terminal side is in quadrant 1, and when you're in quadrant 1 and you have your angle measure that's between 0 and 2 pi, it's just going to be itself, that my reference angle is that angle that lies, because reference angles are always acute angles, and the angles in quadrant 1 are acute angles. So my reference angle as a decimal rounded in radian measure as a decimal rounded to 2 places to the nearest hundredth is 1.07 radians. They wanted the quadrant that negative 5.21 radians lied in, and they wanted the reference angle for negative 5.21. We found both of them. The last problem here, again, it's given in radian measure, and 35.67 is much bigger than 6.28. So let's estimate how many times that we believe, how many revolutions is this making. So if I take 35.67 and divide it by 2 pi, then I believe it's going around, well, no, wait a minute. That doesn't make sense. Let's key this in again. Let's put this 2 pi in that's in the denominator in parentheses. I got to be careful. See, it divided by 2 and then multiplied it by pi. Yeah, a little bit more than 5 revolutions. So if I have this number 35.67, 35.67, and I take away 5 revolutions, and 5 revolutions, each revolution is 2 pi radians. I'm just going to have to clear it. 35.67 minus 5 times 2 pi minus 5 complete revolutions. 4.25. Let's see where 4.25 lies in. 4.25 is bigger than 3.14 but smaller than 4.71. So although you are wrapping around 5 times, we know that this angle is coterminal. It has the same initial side and the same terminal side. So this 4.25, I can use it to say it's coterminal to 35.67 and argue that they both lie in quadrant 3. Whenever you're in quadrant 3, the reference angle is that angle that's in quadrant 3 minus pi radians, minus 180 degrees. So my reference angle is equal to this 4.25 minus the 3.14, but I never like to round it until the very end. It's not going to make a difference. But if I have this 4.25 and I subtract pi, 1.11. That's in radian measure. And what does that represent? It's the angle that this terminal side makes with the x-axis. And like I say, some people like to put radians after that. That's fine, but you cannot put a degree symbol up here because it's not in degrees. And when people see just a number without that degree symbol, they assume it's in radian. All right, so I'm sorry that was so slow, but that's the best I can explain it, and I'll talk to you later.